Formial chloride, the molecule ClCOH, it doesn't exist at room temperature. It's unstable with respect to forming HCl and CO2 gases, highly entropy favored. Industrially, HCl and CO combine under pressure to give the Gadaman-Koch reaction, and then you can have formial chloride. But in the lab, that's not very convenient. Fortunately, there's an alternative. Take DMF and add an activating agent like POCl3, gives formation of O2PCl2 as a leaving group, and displacement with chloride gives the so-called Vilsmeier reagent, ClNme2H. That's a potent electrophile. It's positively charged. It's even better than formial chloride in a way. So it will add to aromatic compounds, especially if they're electron-rich. It will add to electron-rich heterocycles like a treat. Furans, pyrols, thiophenes. It will add to electron-rich alkenes. And after hydrolysis, we form the formial substituted product. What if we don't want to add a formial electrophile, but an RCO plus electrophile, a synthon for that? Well, let's look at an intramolecular version first. We can take an aromatic ring and a string of carbon atoms, and then an amide bond with a C substituent on the amide. Activate that with POCl3 or something like it, and form the corresponding imidoyl chlorides. That's the theme of this talk. Imidoyl chlorides are very useful synthons in organic synthesis. So that imidoyl chloride doesn't hang around, it adds immediately to the benzene ring in a nice six-membered ring formation, and that forms a dihydroquinoline. If we dehydrogenate that, of course, we can get a quinoline, or if we go about it a slightly different way and add an OH into the linking group there, we can dehydrate to get a quinoline that way. That's the C-substituted imidoyl chloride. If we take those C-substituted imidoyl chlorides from amides, but not intramolecularly, intermolecularly, we can add them to aromatic compounds, and that's the so-called Heuben reaction. Or if we add nucleophilic heteroatoms to these, like S, N, or OR, we get the corresponding substitution products, and that is the Pinot reaction. Finally, if we take these imidoyl chlorides and add SnCl2, well, stannous chloride, SnCl2, is a 2-electron donor. It goes to tin 4 chloride, and it reduces the substrate, therefore it reduces on hydrolysis we get aldehydes, the Stefan reaction. So there you have it. Imidoyl chlorides are really useful in organic synthesis. For formial chloride equivalent, Vilsmeier reagent. Adds to benzene compounds, adds to heterocycles, adds to alkenes. If we do that intramolecularly with a C-substituted amide in the right arrangement, we can get isoquinolines. That's the Bishna-Lipinski. That is the Bishna-Napilinska. That is the Bishna-Napalraski reaction. If we take these C-substituted imidoyl chlorides and react them with benzene compounds intermolecularly, that's Heuben reaction. If we add nucleophilic heteroatoms, that is the Pinot reaction. And if we reduce them with tin, that's the Stefan reduction. I think if you tried to learn these reactions individually, it would be quite confusing. But treating them together, it becomes like a poem. Everything is nice and symmetrical, and you can see the developments in the science as they occurred. It's much easier to remember if we unite them all under the heading of imidoyl chloride reagents. Thank you very much for listening. Bye-bye.